Welcome to the lair of the Batty Boffin.
Hi there Batty fans, and welcome to another video all about speed, distance and time from the Batty Boffin. Now you might be watching this video as part of the maths section or as part of the physics section. It doesn't matter, it applies equally well to both. Just to start off with, we're going to look at some speeds that you might commonly have come across. Some of these here, hopefully you'll know, one or two of them are a little more strange. So first thing to do before we go any further is pause the video and see if you can tell me what these abbreviations mean. Okay, pause the video and do that now please. Right, here are some of the more familiar ones. Of course, mph, miles per hour, that's one that's used very, very widely. If you're not in Britain or America, you might be using kilometres per hour, km/h, and that slash is pronounced per. So that's miles per hour, kilometres per hour. Sometimes you see an abbreviated kilometres per hour, like that as well, same thing. Here's one that's used very commonly, particularly in science. Metres per second, m/s, metres per second. Another way of writing metres per second that might look a little stranger is this. That also says metres per second. Now, you may look at that and go, hang on, that's got a power of -1. Well, we understand powers of squares and cubes and things, but a power of -1? How can you have that? Well, there are Batty Boffin maths videos that explain all about negative powers, but just as a little quick look through here, I'm just going to have a look at this one. Metres per second, that of course, that slash is part of a fraction, in the same way that we sometimes write a half like that. So that is actually metres on the top of the fraction and seconds on the bottom of a fraction, metres per second. And a power of -1 is simply a kind of mathsy way of writing seconds is on the bottom of the fraction. So that's metres, normal metres, and then that's per seconds, seconds on the bottom of a fraction. So if you ever see something with a -1 up there, don't panic about it, it's nothing weird, it just means it's on the bottom of the fraction. So those are all quite normal kind of units of speed. I put a weird one in at the bottom down there. Centimetres per year. Well, it's the speed. It's not a very fast one. It's about the kind of speed that your fingernails grow, or it's actually about the speed that Britain and America are moving apart due to the widening of the Atlantic Ocean. That's also about centimetres per year as well. So it's a fairly slow speed, but it's the speed. And we know it's the speed because it is a unit of distance divided by a unit of time. And it doesn't matter how big or small those units are. You could have nanometers per century if you wanted. That's also really, really slow. I'm not quite sure what you'd measure in nanometers per century, but you could, and it would be a speed. So the reason I'm pointing this out is because every unit of speed, whether it's metric or imperial, whether it's a useful one or a really weird one. By the way, try Googling furlongs per fortnight. That's a unit of speed as well. A furlong's a kind of it's an old unit of measure used for measuring fields. It's a furrow length, furlong. So furlongs per fortnight, go find that out, Google it and see what you come up with. All units of speed, that S isn't very good, is it? That's better. All units of speed are a distance divided by a time. And the distance and the time can be anything you like. And that gives us one of our famous formula triangles. Here we go. Formula triangles are a great way of using simple formulas like these. Speed is distance over time, miles per hour. So I can put speed is equal to distance over time. And there's my formula triangle. And that can be used for working anything out when you know the other two. So if you know the speed, you cover up speed and what's left is the formula, distance over time. However, if you wanted to know the time, you cover up the t and what's left is the formula, distance over speed. And if you want to know the distance, that's speed times time. I'll just show you how that works. Let's say you were travelling with a speed of 30 miles an hour. and a time of 2 hours. 30 times 2, that's 60. And yes, 30 times 2, 60 miles. That's the distance you've travelled. Yep, see how it works? Dead easy. So, time for a cup of coffee. And I did have a custard cream, but I've eaten it, which is a shame. I'm going to put some examples up and we'll work through those together. I'll see you in a minute. Right, here's something to have a look at. I've written one question in blue, one in red and one in black. And each one will use our formula triangle a different way. For the first one, you've got something travelling at 20 metres per second. That's nipping along quite a bit there, isn't it, that? So that could be, I don't know, be the speed at which a bird flies. Let's have I live near red kites, they're lovely things. So let's say you've got a red kite who's flying at 20 metres per second for 17 seconds. How far does it fly? The second one, you're doing a journey of 180 miles and you go there in 4 hours. It takes you 100, you're going to be going probably by car in this one. How fast are you going if you cover 180 miles in 4 hours? And for the third one, we're going on the continent here, 440 kilometres at 55 kilometres per hour. This one you might be cycling. I think this might be a cycling race here. It's a very long one. 440 kilometres at 55 kilometres per hour. How long does it take you to do that? Okay, so using your formula triangle, if you need to use a calculator you can do, but these numbers should all be ones that you can do without a calculator. I'll see you in a minute, we'll work through those together. Right, here we go. For the first one, we want to know how far. That's a distance. Distance is speed times time. So we take our speed and we multiply it by the time. Please note that the units all match. That's metres per second and the time is given in seconds. In the next video we'll do some where the units don't match. So 20 times 17, 2 times 17 is 34, so that's 340. And the units for that will be metres, because our speed was metres per second and we've done seconds there, so it comes out in metres. Right, the red one. 180 miles in 4 hours. How fast? We need to know a speed. Speed is distance over time. So we take our distance, 180, and we divide it by the time, which is 4. And again, the units match. That's miles and that's hours, so we're going to come out with miles per hour. 180 divided by 4, that's 180, that's 45. 45 miles per hour. Okay? And finally the black one, we've got 440 kilometres and you're travelling at 55 kilometres per hour. How long does it take you? We need a time. Time is distance divided by speed. So distance, that's 440, divided by the speed, which is 55. Okay, a little bit of cancelling down there. That all cancels by 11s. Hope you noticed that. How many 11s in there? 11's in 44. It's 4 with a naught on there. 40 divided by 5, which is 8. Not 8 kilometres. 8 hours, sorry there. It's a distance. So 8 hours. So that's 8 hours of cycling at 55 kilometres per hour. You need a lot of stamina for that. A little bit Tour de France here, I think this one is. So I hope you got those. 340, 45 and 8 hours down there at the bottom. If you didn't, we'll check back this video again and go through the working, see how you managed that. And if you did, that would be great. I'll see you in the next video where we'll do some of these where the units are not quite so nice. See you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!